Hello friends, today we are going to solve another example of moment distribution method. So here we have a beam, a 3-span beam with both hand fixed, AB span point loaded center, BC span UDL on entire span, CD is eccentric load with 25 kN at 1 meter distance from C and 2 meter distance from D support, and inertia for AB is I, BC is 2I and CD is I. Okay, so as we know that there are 3 steps to solve this. First step, to find fixed end moments. Second is to calculate distribution factors, and based on these two values we'll have to calculate moment distribution. And after that, shear force and bending moment diagram. Okay, so first step is to calculate fixed end moment. First step is fixed end moments. Okay, so first we have AB span. So MF, you can say end moments, MF AB is equals to point load at center. So equation is WL by 8, that is from A to B, and B to A, that is plus WL by 8. So if we put the values, W is 50, L is 4, right? So we'll get the answer 7.5 kilonewton into meter. Here this is plus 7.5 kilonewton into meter. Second, about BC. So B to C and C to B, MF B to C and MF C to B. So here UDL on entire span. So end moment equation is minus WL square by 12. So if we put the value, W is 16, L is 3, square divided by 12. So we will get 12 kilonewton into meter, and this is WL square by 12 plus, so this is plus 12 kilonewton into meter. This is CD span eccentric load. CD span eccentric load. So MF C to D and MF D to C. So this is minus W from C to D, W A V square by L square, and this is plus W B A square by L square. So this is W is 25, A is 1, B is 2 square, and here 25, B is 2, and 1 square divided by 3 square. So you will get the answer minus 11.11 kilonewton into meter for this, and for this you will get 5.55 kilonewton into meter. Before watching this video, I have uploaded 3 videos on my YouTube channel, so please go through that. That example is same as this example, but over there for fixed support I have taken a 2-span only. Here I am going to take a 3-span. Okay, so these are about your fixed end moments, MF AB, BA, BC, CB, CD and DC. Now next step is to calculate distribution factor. Okay, so next step is to calculate distribution factor. Okay, so for that we have to make a table. Okay, so in that we have to consider a joint. So first is serial number. Okay, then we have joint, how many joints are there, according to that joint how many members connected to that, after that stiffness at that particular member, then summation of stiffness and distribution factor, that is K divided by summation K. Okay, so here you have to remember stiffness value. If your ends are simple and ends are fixed, then if your ends are simply supported, you can say and you're fixed. So first we have, see, we have how many joints are there? A, B, C and D. 4 joints are there. So first I will take intermediate joints and after that your end joint. So we have B and C. So let us take first of all joint B. So member connected to your B is BA and BC. Same as for C, CB and CD. Okay, so for B, that are BA and BC. I am take another, that is joint C. So member connected to that, that is your CB and CD. That is CB and CD. And my A and D are end supports. My A and D are end supports, like this. This A and D are the end supports. Okay, so stiffness for B, BA, as far end is fixed, so stiffness for that is 4 EI by L. Okay, next is BC, BC, B to C. As my for BC far end is simple. Okay, for simple my stiffness is 3 EI by L, but there is a continuity of a span. There is another support next to your support C. Though that support is fixed or simple, though that suppose is fixed or simple, we have to consider this support as a fixed support. Okay, so this BC, as C are the intermediate support, that's why. Okay, so BC is 4 EI by L. Same for CB. Okay, so joint C I will take. Then for joint C, CB. So B is a simple support, so stiffness of that is 3 EI by L. But there is a continuity over here, B to A, that suppose is fixed, or either it is a simple, but we have to consider this support as a fixed. So for C to B, my stiffness is 4 EI by L, as my as there is a continuity of a support from B to S. If there is no support here, my actual figure is like this, then this support we have to consider as a simple, as there is no continuity. Here there is a continuity. So as there is no continuity, we have to take CB stiffness as a 3 EI by L, but there is a continuity, so we have to take as a 4 EI by L. So CB is also 4 EI by L. What about my CD? CD is far end is fixed. Okay, so that is 4 EI by L. Okay, so now here these are the end supports. Okay, so 4 EI by L for all the cases. So first for B to A, my inertia is I. For AB span inertia is I, BC span is 2I, and CD span it's I. Okay, so for EI by L, so 4 EI by length is 4 for AB span, so that is 1 EI. Okay, again this is 4 B to C. Now B to C I am having a 2I inertia. Okay, so 4 E 2I by L is 3. So that answer I will get, that is 2.67 EI. Now again 4 EI by L, C to V. C to V I am having a 2I inertia. So again 4 E 2I by 3. So that answer is again 2.67 EI. This value I have calculated already. You just keep your calculator with you and calculate this value accordingly. This is 4 EI by L. So 4 EI by CD is only a I inertia, 4 EI by 3. So this answer is 1.33 EI. This is about individual. Now summation of these two. Okay, if I separate it, okay, so stiffness, summation of all stiffness. So 1 plus 2.67 EI. So that is 3.67 EI. This is 3.67 EI and this is 2.67 plus 1.33. So this is 4 EI. Okay, so distribution factor for, see, we have to calculate distribution factor for every member. Okay, so for BA, that is K divided by sigma K. So K is, for BA, K is 1 divided by sigma K is 3.67. Okay, so 1 divided by 3.67, so that is 0. EI get cancelled, and 1 divided by 3.67, that is 0.27. Again this is 2.67 divided by 3.67, EI get cancelled. This answer is 0.73. Same for this case, 2.67 EI divided by 4 EI, so that answer is 0.67. and about this 1.33 divided by 4 EI, so that is 0.33 EI get cancelled. Now what about this A and D end supports? What about this? This is about your intermediate supports. What about your end supports? So ends, whenever your ends are fixed, it means if you are having an end as a fixed support, then your distribution factor, you will have to take it as a 0. So A is my fixed support, so distribution factor for that is 0, and my D is also fixed support, for that also my distribution factor is 0. And if my ends are simple, then I will have to take distribution factor as a 1. Okay, so this is all about a two-step fixed end moments and distribution factor. If these two values are wrong, you will not able to get your final answer. You can say you cannot calculate moment distribution if these two answers are wrong. Okay, so this is first step, fixed end moments and distribution factors. Now next step is to calculate the moment distribution. Okay, for that I have prepared a table like this. This is nothing but your values, calculated values, distribution factor and fixed end moment. So your third step is your moment distribution. Okay, so if you look at this figure, this is your A, B, C and D. Your whole beam is there. These ends are fixed. Okay, though, so that you can see the distribution factor at the ends are 0, 0. These are the fixed end moments that you have, what you have calculated over here, like these values, and distribution factors is your these values. Okay, so distribution factor value we will have to write on the top side, and fixed end moments values we have to write on a next line. Okay, so these all are the unbalanced moments. See, so we have to balance it. These fixed end moments are unbalanced moment, we have to balance it. So in this moment distribution method, distribution of moments are there, so we have to distribute the moments from one support to the another supports. You can say one end to the another end based on your end conditions. So what we have to do, we have to balance the moments. Okay, so these are, see how you can say that my all balance are sorry, my moments are balanced or not. At the last, your moments are equal and opposite at the joints. At the intermediate joints, your moments are equal and opposite after the calculation. So here you are not having a balanced moment. These are the unbalanced moments. For a balanced moment at joint, your balance are equal and opposite. Okay, so we have to balance it. How you can balance? So first we will have to take, you can say first we have to balance. Okay, so how you can balance? So initially you know that your support are fixed supports, so start from the supports whenever you are having ends are fixed. Okay, so assume that this end support as a 0 0. So balance like this. See, we have to balance all simultaneously whenever we are having a fixed support. Okay, so assume my ends are 0 0. Okay, so we have to directly assume for a end support as a 0 0 balance value. Now what about the intermediate? This calculation what I am going to do right now, that is totally when you are having a fixed support, then and then you will have to do this procedure. Okay, so to balance intermediate, suppose we have to, what we have to do, we have to add this end moment 7.5 plus minus 12. That answer I will get, that is minus 4.5. Minus 4.5 multiply with individual distribution factors, and opposite of that you would have to write. So 7.5 plus minus 12, that is minus 4.5. Minus 4.5 multiply with 0.27. So that answer you will get minus 1.21, but opposite of that you will have to write, so that is plus 1.21. same for that, that is minus 4.5 multiply with 0.73. so that answer is minus 3.28, but we have to write opposite of that, so that is 3.28. same for this case, that is 12 minus 12 plus minus 11.11, so that answer is 0.89. so 0.89 multiply with individual distribution factor, so 0.67 and 0.33, so that answer is 0.89 into 0.67, so 0.59 plus, but we have to write a minus value. Same for this case, that is 0.89 multiplied by with 0.33, so that answer is plus 0.30, but we have to write opposite of that. So this is your first balance. Okay, so all things are balanced, we have to assume at the ends as a 0 value, and intermediate support we have to calculate like this: addition of end moments multiplication with individual distribution factor. Okay, and opposite of that answer you have to write over here. Now this is balance. Okay, after that, see how you can check we have to go further or not. Okay, so for that, addition of these two, 7.5 plus 1.21, that answer, and minus 12 plus 3.28, that answer should have match compulsory, but here it is not happen, so we have to carry over it. How you can carry over? How you can carry over from one to another? As we are having and supports over there, and supports are there, so cross carryover can happen. What carryover? Cross carryover. So cross carryover from one support to the another support, like this one support to the another support. So carryover is happens from one support to another support, but value of that is half value. As we are having a 0 value, 0 carryover to here, so that value is half is 0. Again 1.21 divided by 2, that is 0.60, that is 3.28 divided by 2. Carry over half value 1.64, 0.59 divided by 2, so that is minus 0.30. Okay, and 0.30 again, this is 0.15 but minus value, and here this is a same as 0 value. Okay, so after carry over we have to again balance it compulsory. So again balance, after balance you have to check whether you will get at intermediate joint equal and opposite answer or not. So here after this balance we have checked but it is not matched. Okay, again here balanced. So how you can balance, same like this step what we did. So initially assume these values as a 0 0. Okay, now addition of these two 0 plus minus 0.30, that is minus 0.30 multiply with 0.27, so that answer you will get minus 0.08, but we have to write opposite of that, so that is 0.08. same for this case, that is 0.22, 0.30 multiplied by 0.73, minus answer you are getting, but opposite of that we have to write. Same for this case, 1.64 plus 0, so that is 1.64 multiply with 0.67, so you are getting plus answer, we have to write minus, that is 1.10. So 1.64 multiply with 0.67 and 1.64 multiply with 0.33, so you are getting this answer as a minus 0.54, like this. Again I am checking all these answers, 7.5 plus 1.21 plus 0 plus 0.08 minus 12 plus 3.28 minus 0.30 plus 0.22, but that answer are again not matching. Okay, so we have to again carry over and balance. Okay, carry over. So how can I carry over? Carry over again, a cross carry over is that when your ends are simple you have to do cross carry over like this and carry over the half value. So 0.08 divided by 2, so that is 0.04. This answer is again 0. This is minus 1.10 divided by 2, so that is minus 0.55. This is 0.11, this is 0, and this is 0 minus 0.27. Now again you have to balance. After carryover you must have to do a balance. Okay, so how you can balance? Again initially assume 0 0, addition of this, so addition of 0.55, 0 minus 0.055, sorry, 0 plus minus 0.55, so that is minus 0.55 multiply with 0.27 and 0.73, so you are getting the answer minus value, but opposite of that you have to write, that is a plus answer, 0.15. again this is 0.40. same for this case, plus answer you are getting 0.11 plus 0, so you have to write it a minus 0.07 and minus 0.04. okay, now again you have to check 7.5 plus 1.21 plus 0 plus 0.08 plus 0 plus 0.15 and minus 12, 3.28 minus 0.30 plus 0.22 minus 0.55, 0.40. Here you are getting a somewhat similar answer, but I will do another next step, you can say next carry over and balance for more accuracy. Okay, so here also you will get the, but minor point variation is there. Okay, so again I will do a carry over for this. Okay, so how can I carry over this? Again a cross carry over like this. Okay, so 0.15 divided by 2, that is 0.075. this is 0, minus 0.02, minus 0.035, minus, sorry, plus 0.40 divided by 2, that is 0.20. This is 0 and this is minus 0.02. This is carryover. After carryover, what you have to do? You have to balance. So how you will balance? Again, assume this as a 0 0, addition of the 0 plus 0.00, sorry, minus 0.035. so that answer is minus 0.035 multiply with 0.27 and 0.73. so you are getting the answer minus answer, but we have to write as a plus. So 0.009 and this is 0.026. this is 0.20 multiply with 0.67 and 0.33. so answer you are getting is plus. We have to write minus 0.30 and 0.07. okay, so sum from here, from the top portion. So 7.5, if you add all these values, see, this is the different thing, but at intermediate joints you will have to get equal and opposite answers. Say if I add all this 7.5 up to 0.009, so I am getting an answer for this, that is 8.95 plus answer, and at this minus 8.95, summation from this point, summation from here. So addition of this all is 8.95 minus 8.95. until you are not getting this equal and opposite answer after balancing your moments, you have to continue your calculation. okay, so same for this case. 12 at C joint, 12 minus 0.59 plus 1.64 minus 1.10 up to minus 0.13. so you are getting the answer 12.06 and this is minus 12.06. same, this is the different thing. so you are getting minus 6.79 at A support moment and 5.11 at D supports. This you are getting, that is your final moment. How you will come to know these are my final moments? For final moment at your joints, at supports, your moments are equal and opposite. The moments are equal and opposite. okay, so if I will write an answer, so my MAB is minus 6.79 kilonewton into meter. My MBA is 8.95 kilonewton into meter, and my MBC is minus 8.95 kilonewton into meter. These two values are equal and opposite. Now my C2B, that is 12.06 kilonewton into meter. C2D, that is minus, so this is plus and this is minus 12.06 kilonewton into meter, and this is MDC, that is 5.11 kilonewton into meter. These two values are equal and opposite. So in a moment distribution method, you have to remember that at my joints moments are equal and opposite. Until that, you have to calculate your calculation, your fixed end moment, balance that moment and carry over, again balance, again carry over. okay, so this is all about your numerical of 3 span with ends are fixed. 3 span and ends are fixed. Whenever ends are fixed, you have to continue with cross carryover, and that carryover moments are half moments. You have to carry over from one support to another support a half value, half moments, and distribution factor for when ends are fixed 0 0 values. Okay, so go with that moment distribution numerical. Thank you.